Welcome back to our podcast. This is our first one for 2026, so I'm very excited. Today we're diving deep into the world of sustainable ocean technology, speaking with a true pioneer who's enabling long-duration ocean exploration without the need for traditional batteries. Our guest is Dr. Chao, the founder and CEO of SeaTrec, which is a company that's revolutionizing ocean data collection by developing technology that harnesses energy from temperature differences in the ocean, powering underwater vehicles and sensors for months, even years at a time. Yi brings a wealth of experience from his background at NASA and the Joint Propulsion Lab, where he developed this technology, and he's now leading SeaTrecs to commercialize it, transforming how we monitor and understand our oceans. So Yi, welcome to the show. It's fantastic to have you here.
Thank you for the opportunity.
Thank you. So you spent years at NASA and the JPL working on this problem. Was there a particular aha moment for you or pivotal moment that led you to realize that thermal energy harvesting was a viable solution for powering ocean technology and something that could fundamentally change how we do monitoring at scale?
Yeah, it took me 20 years to reach that aha moment, and I have a PhD oceanography. I always fascinated to study the ocean using a variety of different tools. So my PhD is developing computer models to simulate the ocean, try to forecast our ocean. After my PhD, I worked for NASA Jet Propulsion Lab in Los Angeles. Try to study ocean from space because ocean is large. We only have few ships and very tedious and time-consuming, expensive to go to sea. And so I thought that study ocean from space, provide this daily snapshot of the ocean, satellites flying in the sky. You can get a global coverage. So I spent almost a decade to develop the first salinity satellite to measure ocean salinity from space. That's a pioneer instrument NASA developed. And then eventually we launched the satellite in 2011, collect data for 3 years. We circled collect a global map of salinity every week. So for the first time, we can study the ocean on a daily, weekly basis instead of doing an expedition every year, every decade. So that's opened the eye of kind of a satellite oceanography, study ocean using satellite data. And then drive me frustration is really hard to study below the surface because satellite cannot see through. We spend hundreds of millions of dollars, but I only see the skin surface a few millimeters. So that's really get me interested in underwater robotics and then doing research. And I realized what's a bottleneck for robots in the ocean. And simply there's no charging station in the ocean. All the robots in the ocean running out of batteries. So it's actually very expensive. Not only we need a robot, we need ships to recover those robots when the battery runs out. So that's kind of the moment I realized I want to devote another decade to study how do we extend the lifetime of robots, became more capable to carry a variety of different sensors. Really the goal is to how do you extend the data from the surface to seafloor. So that's really kind of my passion and then decision to quit my job and then study SeaTrec.
Okay, that sounds like a very long but very productive journey. The salinity mapping by itself would be incredibly interesting to delve into. But for a technically curious, I guess, but non-specialist audience, can you walk us through the core physics of SeaTrec's thermal engine and just as importantly, what does it mean for the operational lifespan of a typical underwater drone or robot sensor?
Yeah, typically if you run any drones and then the mission is limited by batteries to energy stored in the battery. So you can fly a drone, they last for hours and they have to swap batteries and recharge batteries. And so that's really one of the biggest challenge for underwater robots because there's no charging station easily available. And then typically the ships waiting to collect the robots and then recharge them. Typically you waste more time, more money than the robot itself. So that's make the robotic really not sustainable. So there's a pioneer oceanographer, Henry Stommel, wrote an article almost 30 years ago before the robotic become a mainstream AI, saying ocean have unlimited energy, thermal energy on the ocean. When you dive into the ocean, the deeper you go, the water become colder. So that's a thermal contrast in the ocean. We call the thermocline. It's unlimited energy we should tap into to power our sensors and robots. Took me 20 years later to discover that article in the Oceanographic magazine. That's an incredible hypothesis, and then we put together engineering team saying they convert this very small temperature difference in the ocean into electricity. So essentially we turn that 10, 20 degrees C temperature gradient into electricity. So all the robot need to do is to move up and down, feel the cold water depths with a warm water surface. When they go through the motion vertically, they automatically charge the battery in the ocean. Essentially, you have a robot can be continually get recharged. So if you deploy and they last, essentially from energy point of view, have unlimited endurance. So that's really the gist of this technology to extend the mission life and have ability to carry more sensors and payloads. And we are not able to do today with limited energy supply for a battery.
Right, that's amazing. So it can potentially operate for years, floating around under decades. And what are the limits then in terms of other things that might be impacting on it, like running into things, getting damaged by corrosion, or other things that influence its capacity to be out there for that long?
Yeah, ocean is very challenging environments. We lost things in the ocean. So for reasons time, you can anything in the ocean can be, hit by a boat. The whale get killed by
Yeah.
container vessels. Ocean is challenging by biofouling, things grow, you need to clean regularly. So those are the external factors limiting the endurance of the vehicle. And then you can also have limited moving parts and recharging cycles, like your iPhone or like a smartphone. After a couple of years, your battery charging slower and slower. So there's a limit how many cycles you can charge your batteries. We have a lot of moving part to harvest energy. Also, any moving part like your car, you can eventually wear and tear. So there's a variety of different internal, external factors and influence endurance. But the EV envision lasts for at least a few years.
Right. And so there'll be the tracking devices on them. And so if they are starting to slow down or something, that there's the capacity for the ships to go out to pick them up and to do any maintenance or repair activities on them.
Some of them, we do have a tracker, and every time the device at the surface, we can track them with the satellite through GPS position. If you know the position, if they are alive, and then you can recover them. Many of the chance instances, the robot just stopped talking to you. So we just don't know where they are. They could fail 100 meters below the surface. And then if they don't tell us where they are, we cannot recover them. We just
Right.
don't know where they are. Maybe the failure mode at the surface we can recover. If they fail below the surface, we don't have a continuous communication device underwater. So most of the acoustic positioning is very short range. We don't have enough beacon and relay stations to track them below sea surface.
Okay. So when that sort of long-term battery power stops becoming a limiting factor for things, what do you think is changes in practice for the sort of missions around ocean monitoring and mapping? It's how they're designed, how often data can be collected, sort of who's able to deploy these systems in the first place?
Yeah, deployment is challenging. We are improving our packaging so we can deploy our system easily through any vessel, not only research vessels. So we are able to deploy them in a ship opportunity like container vessels or cruise ships or sailing vessels. People
Okay.
go out. We can ask them to drop the device in a certain location. So where otherwise would cost a lot of money to charter a vessel go to the middle of the ocean. So deployment is one thing we are improving. And also the cost, we try to reduce the cost of the device so we can deploy many of them, fleet of these vehicles and cover a much bigger area. So that's another area we're working on. It just makes the system more reliable so that it can last longer and is more capable to carry different payloads.
Okay. And so, moving from your prototype to a commercial product, particularly in this type of space, is notoriously difficult. Interested in what sort of assumptions you held early on that have turned out to be wrong once real customers and real ocean conditions have entered the picture?
Yeah, this is a tough space working in the maritime startup. Working hardware is difficult in general. Hardware in the ocean even more difficult. As you can see, the testing cycle is very long. Take long time to reserve a ship to go out to test. And then when the results coming back to iterate and go back into the ocean, so automatically that's make the cycle very long. So put a challenge for the startup companies who are limited in the capital. We don't limited resources. And then as a private company, we have to raise money from private and government philanthropic and then foundations. So that's probably the challenge to cross this valley of death in this space, define the minimum viable product and then bring to the commercial market quickly. And that's really the lesson we learned. Took us many years to bring to a commercial. Now we have a revenue. Now we can scale up and then make our commercial product more reliable. We can sell more and then give us a little more time and resources to continue to do R&D, improve our product further.
Yeah. And so who's adopting your technology fastest today? So who's most interested in it? Is it mainly sort of oceanographic mapping or mining companies, underwater exploration?
Yeah, all of those above. Our early adopter, we are focused on the research community, some kind of research market as a for early adopters, and we are working with them directly to improve our system, try to understand the limitation, the capabilities. So research market, researcher from universities, research lab organization, NGOs, and government laboratories. Those are kind of friendly early adopters early on. And then do use technology, and then the product can be used by defense organizations as well. And then hopefully as the product become more reliable, cheaper, definitely we're interested to scale up to the industry like offshore shipping, mining, fishing. Anybody use the open ocean, require data in the ocean. We hope to work with them, provide that missing gap.
Okay. And is there any then connection between the data being gathered between all those different projects? Is this pitching together all of the ocean mapping side of things that might be being undertaken?
Yeah, our customer is up to our customer. Many of the researchers measure temperature salinity in the ocean here globally real time. We are working with Seabed 2030. Once we map the seabed, and then we're going to share with the community. As you know, 75% of the ocean is unmapped. So we want to contribute using our device to scale up the efficiency to map the 70 of the global ocean. And there are customers, the industry, the government, defense customers, and they want to keep the data themselves. And then they probably will release later on as the less sensitive in terms of industry competition and then military applications.
So we're trying to commercialize this product. I guess you're dealing with lots of different clients. Are there particular challenges you face yourself as a newly commercializing company with dealing with, I guess, different procurement and processes and having to go through all that sort of administrative side of things to try and get the uptake of your product?
Of course, yeah. 10 years ago, I don't know how to run a company. I'm a scientist, I'm a researcher. I work with the government, with NGOs to understand the ocean, explore the ocean. Of course, now we are a startup for-profit companies and have a commercial product, and we have to support operation. That's certainly a learning experience for me as a non-traditional startup. It's not a college dropout and then have a aha moment, get a Facebook, and then into the place, and then you get 1 million users in 3 months, right? So we are in this very challenging space. Sometime I have multiple hats. I have to raise money. I have to do the sales. Another day, I could write proposals with the government, and then working with the customer support, and then working with the investors. So I guess it's early stage. Is like every startup is very challenging. The founder, CEO, can be playing many different roles, and then we are budget limited. We always limited by capital. We cannot raise unlimited money to hire big team in the beginning. We are still pretty small, kind of still in the scaling up phase. So for me as a scientist, transitioning to a founder and CEO certainly is a lot of lesson learned in the last 8-9 years, and then so it's
It
an
might be.
interesting, exciting
Is it
journey.
interesting or personally challenging for you? I guess some of those things take you away from your areas of passion, which is really around
It is
developing the
challenging in
technology.
the beginning because I suddenly kind of pushing through the boundary of my comfort zones and to read books and then talking to people who have done it and have experience. I learn from them. Of course, you made a mistake and then along the way, and then you correct yourself, and then a lot of lesson learned. But eventually, I really enjoy that journey. And then I thought this is, it would be nice. I learned this in college and in school, so I get better prepared. But hey, I don't know until 10 years ago.
That's right. Well, we all have different journeys, don't we? And so I guess going back, are you currently using or exploring the use of any AI tools to optimize your internal operations?
We
Either for predictive maintenance or for,
yeah,
yeah.
we are maybe many years behind. We are kind of leveraging the AI tools. And then in our space, we are data poor in the community. So we don't really have a lot of data in the ocean. For example, if you look at the global map in the ocean below the surface, we can count our data with, tens and hundreds of data points. We need millions of data points, for AI to put in the work to make that decision. So it's always a challenge in ocean. How do you gather more data so you have a sufficient enough data to turn that into information decision making? Today, we are several order magnitude behind the curve for AI to be effective. So kind of, we are very excited about the AI tool become available, hopefully in 5 years from now. And then we have enough ocean data in our smartphone so we can easily use AI to make smart decisions and then tell the shipping company to slow down if you see a whale in front of you, or you tell certain operators and then to map, how deep the ocean is and what the sediment look like, and then what the health of the ocean for fishing companies, offshore aquaculture, that kind of thing, selecting, what's the impact of environments for mining in the ocean. So we just don't have a lot of those data today to inform our decisions.
Have you thought about using AI for your internal, more administrative processes around your marketing and sales efforts, that sort of thing? Or dealing with all of the writing the proposals to different funding or procurement bodies?
Yeah, we are still early stage. So certainly we deal with government quite a bit, and then for the early risk reduction activities. So government still play a role. One thing I'm really lucky to be able to find some philanthropic foundations to help us to reduce those risks. So we don't have to rely on private capital, which is very expensive to raise money. But having the government and the philanthropic support, and they have longer horizon than the private funds, and they certainly have more ambitious vision to help us to reduce the risk for the developed technology. So make our commercialization effort a little bit easier.
Yeah, okay. So looking ahead 12 to 18 months' time, what's your biggest single constraint that is most limiting your growth right now?
Right now, we are limited by the manufacturing capacity. So we have a minimum viable product. A year ago, it's really great to see the sales coming in. And then some of the customers start to challenge about delivering time is too long, how quickly you can manufacture. So it's like a chicken egg problem. You don't order 100 or 1,000 units until we set up the factory. The question is, how do we scale up to anticipate the demand, and then we don't kind of overscale and too much. So that's really the challenge for us in the next 18 months to figure out that healthy scaling up to meet the demands. But at the same time, people don't have to wait 6-9 months today to get at the robots. So how do you reduce that cycle? We've never been Amazon just in time for deliver tomorrow, but can we reduce that 6-9 months to maybe 3 months or even shorter? So people don't have to wait long to get the device and then put it in the ocean, start collecting data, make decisions right away.
So you're manufacturing them yourselves at the moment, or you've got a sort of a single manufacturing plant that you're working with? Is that you're hoping to scale up? Is that how it's working?
We're in San Diego, so we are more designing and assembly infrastructure in San Diego in our facility. We try to outsource many of the components to other local machine shops and try to reduce the need for infrastructure
Mm-hmm.
of the company. So we don't have to raise a lot of capital to buy machines, and then so we can outsource them within driving distance in Southern California, and is managing supply chain as part of the manufacturing scaling up activity in the coming years.
Yeah. Okay. And just again, looking at your vision for the future, do you have visions for other technologies that can use this type of energy harvesting?
Yeah, we are continue to do research development. We are still getting government funding to further improve our technology. In addition to the product we launched, and a kind of portable system, profiling up and down in the ocean. We're going to increase the system, become a bigger size. Like the cars, you have different size of the vehicle.
Hmm.
So we suddenly want to scaling up to make a powerful device, and then so we can accommodate more sensor payloads. We have a project developing charging station, for example, really separate the vehicle from the energy harvesting. Analogy is you don't want to carry too many batteries on your car because it's getting less efficient if you carry more batteries.
Hmm.
But then you have charging station along the road. So how do we get a charging network in the ocean? We also developed a charging station in the Arctic on ice, so we can harvest energy from the air-sea temperature difference. So the next big revolution is developing this charging system, and then once that mature in a few years, and then we can start to install the network. So not only charging our vehicle, we can also offer the charging station to the vehicle manufactured by other companies. There's hundreds of underwater vehicle companies, and
Right.
they face the same problem. Battery runs out, you have to recharge and then change them. So
Okay.
having that underwater charging station in the Arctic as well, and then we slowly enable more robot in the ocean, and and then we just need everybody to extend their lifetime to collect more data, and then it just take many order magnitude scaling up to really understand the ocean anywhere and anytime.
Are there any limitations there in terms of where the physics of the thermal energy recharging works? So you mentioned you're working the Arctic, so obviously you can work in really cold temperatures like Antarctica as well as the tropical zones.
Yeah, the thermal energy harvesting, you have to have a thermal gradient. There are certain area you have absolutely no temperature difference. So then you cannot harvest energy. Then we have to rely on more batteries and then more charging not too far from the place you cannot charge. And then eventually the robot is powerful enough to move into the area you're interested. So we are limited by that physics. And there's 10-20% of the ocean have no temperature difference. Uniform, you go to Arctic Ocean, Antarctic Ocean, surface is cold, the bottom is cold. You only change maybe a couple of degrees instead of 10 degrees.
Okay.
So that's why we developed the energy harvesting through the cold air, and in that water is warm. So we're looking that gradient doesn't have to be in water as long as you can find a difference, temperature difference. So our Arctic power station harvesting between the warm water and the cold air in the winter time. So we are continue to improve our technology to kind of extend the footprint to everywhere, and that's really the goal and then where we see this heading to.
Okay. And are you aware, is this as the first working example of using this thermal harvesting principle to actually develop a product that can be used in a commercial sense or a large scale sense?
Yeah, the in terms of the portable system, we are the first one to make it happen. And there has been activity try to do OTEC, ocean thermal and energy conversion, try to power islands and so forth. And then that's kind of the cost prohibitive kind of abandoned that kind of activity to scale up for powered islands and the infrastructure. It's just very costly compared to wind and the waves and then other form of renewable energy. So we cannot scale down to this like a portable system to use as effective enough to harvest small amount of energy in a reasonable cost and then to power sensors and the payload in the ocean. That's really the breaking point for our technology. Instead of proposing power the entire community, we just power the robot. Now you don't need the megawatts, you just need maybe a few watts, and then even fraction of the watt is still useful.
Right. And do you think that there's any sort of risks in terms of sort of the sustainability impacts on the ocean itself? With I'm envisaging down the track hundreds of these or thousands of these little robots running around under the ocean. Are there pollution issues with interference with wildlife and migratory patterns and all that sort of stuff that might cause problems if you do get to scale up to the sort of the level you're talking about?
Yeah, that's the beauty of our technology. We are clean, renewable, and we are closed system. We don't interact with the water itself because we are closed system. That's contrast to all the previous old tech plants pumping water. You have impact to the marine life because we are using different materials, not the ocean water, to harvest energy. So our system is completely closed. The only damage environmentally is eventually if the robot fails, if you cannot recover, and it's become a waste in the ocean. So we already right now today we abandoned thousands of these battery power system already. With our system, hopefully it will reduce those waste, several order magnitude. And then how do you recover those? Building the system, if it fails, come to the surface, you can get recovered by the ship opportunities. And so those are the additional things. And then to make sure you have a zero waste left behind. With our technology, we are already reduced the number of waste of these, dead battery system by several order magnitudes already.
Right. That's good to hear. If you were to wave a magic wand, this is my sort of last question I usually ask everybody. If you were to wave a magic wand to remove one big issue or to solve one problem that you've got, apart from you mentioned the manufacturing scale up one, what would you be doing to really position you to help achieve the vision you've got for SeaTrec and your technology?
Yeah, the challenge is the capital. If I have unlimited capital and I can create a robotic network and I create a global data set like a Google Earth for the ocean, for example, if you go to Google, type in 50-meter below the surface and then return nothing. So I think if I have enough capital, eventually it potentially will be, and then you can deploy sufficient number of these vehicles and then collect all the data ahead of the time so people can go use AI to make decisions. And instead of taking a decade or two to reach that point, and then it would be nice we can get it sooner. But that does take a lot of capital to deploy thousands, millions of these devices in the ocean. Then you become a big database, enable AI to make smart decisions. So I would imagine if I have a magic wand to reduce that time, I'm sure we will get there in a decade or two. But if we can reduce into 5 years, that would be a miracle. To have 5 years from now, we should know everything about the ocean. Instead of today, we only need a few percent knowledge anywhere in the globe.
That's a fantastic vision to have. I hope you get there. You certainly sound like you've broken through quite a lot of barriers to get to where you are now. So I have no doubt that you'll continue to be successful. It's been an incredibly fascinating conversation. I really appreciate the time you've taken to chat to me today, and I'm looking forward to keeping track of what's